Alright, good day students. It's chemistry class once again, and we shall be considering hydrolysis of salt. We've treated salt extensively. Now let's look at hydrolysis of salt. Now, what is salt hydrolysis? When we hydrolyze salt, what we do essentially to the salt is that we are reacting it with water to form solution. Now, the solution formed can be acidic, it can be basic or neutral. Now, the responsibility now lies on us to be able to predict what kind of solution will a salt produce when it is hydrolyzed in water. Now, the best way to do that is to analyze the salt. Ask yourself some few questions. Is this salt formed from a strong acid or a strong base, a strong acid or a weak base, or a weak acid and a strong base? Now, we are going to be looking at different categories of salt. Now, let's look at examples of salts formed from strong acid and strong base. Example is sodium chloride and potassium nitrate. Now, how do I know that these salts are formed from strong acid and strong base? For example, look at HCl. Look at HCl. Now, HCl, the sodium here shows that the base that formed this salt is sodium hydroxide, while the chloride here shows that the acid that formed this salt is hydrochloric acid. Now, sodium hydroxide and hydrochloric acid, they are both strong base and strong acid. Now, any salt formed from strong acid and strong base, when they hydrolyze such salt in water, they produce a neutral solution. Let me take that again. Salts formed from strong acid and strong base, when hydrolyzed in water, gives a neutral solution. Another example is potassium nitrate. The potassium nitrate salt was formed from potassium hydroxide and HNO3, which is nitric acid, which is a strong acid. So, having been able to predict the acid and the base that form the salt, we can therefore form conclusion about the kind of solution the salt will produce on hydrolysis. So that's the first case. Let's look at another case. Now, when the salt is formed from strong acid and weak base. Now, some salts are formed from strong acid and weak base. Now, if you look at aluminium chloride here in example 2, aluminium chloride is a salt. Now, this salt is formed from aluminium hydroxide, which is a weak base, and HCl, which is a strong acid. Now, when you hydrolyze this kind of salt in water, it will give you a strong acid and a weak base. So the solution will be acidic because the acid is strong. So the entire solution will be acidic. So another example is ammonium chloride. Ammonium chloride is formed from ammonium hydroxide, which is a weak base, and hydrochloric acid, which is a strong acid. So the solution formed on hydrolysis will be acidic. It's as simple as that. Now, what you just need to do is to be able to predict the kind of acid and base that formed a particular salt. Now, having known that, you will be able to tell whether the hydrolysis of such salt will produce an acidic solution, a basic solution, or a neutral solution. Then the last case is this: when the salt is formed from a weak acid and a strong base. A weak acid and a strong base. Such salt will dissolve in water to produce a basic solution, and common example are sodium triazocarbonate and potassium triazocarbonate. Now, sodium triazocarbonate is presumed to be formed from sodium hydroxide, which is a strong base, and hydrogen triazocarbonate 4, which is a weak acid. Because the base is strong, the solution will be basic. Any species that is strong in the solution will take over what the solution will look like. For this kind of salt, that the base is stronger, the solution will be basic. So it's as simple as that. So you will be given different types of salts and you will be asked that, oh, what kind of solution will this salt produce on hydrolysis? So the responsibility lies on you to be able to predict the kind of acid and base that formed a particular salt. Just by looking at their constituents, we're able to predict here that it was formed from sodium hydroxide and HCl, here aluminum hydroxide and HCl, here sodium hydroxide and HCl. Now let me make it simpler for you. The common strong base we have, they are sodium hydroxide and potassium hydroxide. Sodium hydroxide, potassium hydroxide. While the common strong acid we have, they are HCl, H2SO4 and HNO3. So that is that about salt hydrolysis. Okay, this is I will still have to, this is just a mechanism to tell us why, what happened, what all I just explained. Now this is the salt. Let's study this schematic diagram. This is the salt, this is the water. Now on hydrolysis, the metal on the salt will split, while the non-metal, the cation, the anion will also be split. Now, two things can happen. It's possible for the metal, which is assumed to be the acid, to react with water to form an MaOH and hydrogen ion. Another possibility is that the anion can also react with water to form Ha and OH minus. Now, each of these pathways have their equilibrium constant. Now, if the equilibrium constant of Ka is equal to Kb, then the solution is neutral. That is, any of the two is possible. Now, if the equilibrium constant for Ka is higher than that of Kb, if you look at Ka is the one that produces the hydrogen ion. And I've told you earlier that acidic property can be defined by hydrogen ion. Any solution that produces hydrogen ion is always said to be acidic, while any solution that produces hydroxide ion will be basic. So if Kb is less than Ka, it means the solution will be basic. So this is the mechanism. It's not just enough for you to know that, okay, strong acid, it will produce acidic solution when it reacts with a weak base. This is just to show you what is actually happening to the solution at equilibrium. So this is also put here to further elaborate on what I've just explained. Now, some substances, whether acid, base or salt, they are classified under these three properties. Some are said to be efflorescent, some are deliquescent, while some are hygroscopic. Now, you just have to learn this definition and you should be able to give an example of a fluorescent substance, deliquescent and hygroscopic substance. Now, what is an efflorescent substance? Efflorescent substances are substances that when you expose them to the atmosphere, they lose all or part of their water of crystallization. Now, some salts has water in their structure, in their crystalline structure. That is, crystalline salts, they have water inside their lattice. So when they are exposed to the atmosphere, there is tendency for them to lose part or all of their water of crystallization. Such salts, they are called hydrated salts. Salts that lose part or all their water of crystallization are called hydrated salts. Example is copper sulfate pentahydrate, that is CuSO4.5H2O. I'm sure you must have come across that compound when we were treating how to calculate molecular formula. So that's efflorescence. Now, deliquescence now is a phenomenon whereby compound absorb water from the atmosphere and then they dissolve in it by forming solution. So some substances have the ability to absorb water from the atmosphere when they are exposed, and after absorbing the water, they now dissolve in it to form solution. Such substances are called deliquescent substances. An example is potassium hydroxide, iron 2 chloride, sodium hydroxide, calcium chloride, and magnesium chloride. Now, we also have another set of substances. We call them hygroscopic substances. So what's hygroscopy? It's a phenomenon whereby substances absorb moisture when they are exposed, but they do not form solution. Rather, they become sticky. So the difference between deliquescent and hygroscopy is that deliquescent, on absorbing the moisture, they form solution by dissolving in it, while in hygroscopy, they do not form solution, they rather become sticky or moist. An example is sodium nitrate, copper oxide, calcium oxide, and concentrated H2SO4. Now, there is something common to deliquescent and hygroscopic substance. Because of their ability to absorb moisture, they are mostly used as drying agents. We use them to dry gases when they are produced. You don't want your gas wet, so you just pass the gas over any of these substances and it dries it. Common drying agents are concentrated H2SO4 and calcium chloride, even calcium oxide. They are important drying agents in the laboratory. So that is that about salts, hydrolysis of salts and the properties of some compounds. So I have an assignment for you. Oh, it's not so clear. All you just need to do is probably, if you can zoom it or just take your time. The first question is for you to complete this reaction. Is a neutralization reaction. While the table here, I've given you a series of salts. You are to predict the parent acid and the base that form the salt, and you tell me if the solution is acidic, basic, or neutral. So thank you for watching. Do this assignment and submit before 12 o'clock tomorrow. Thank you.